This question belongs to the topic of network theorems and the subtopic is reciprocity theorem. The difficulty level of this question is easy. The approximate time required to solve this question is around 45 seconds. So in this question it is given that a two-port resistive network is given as shown in the figure. So for this two-port resistive network, it is called as two-port because there are two ports, that is port 1 and port 2. This is port 1 and this is port 2. This is also called as the input port. This is also called as the output port. So he is telling that an excitation of 5 volts is applied at port 1 and port 2 is shorted. So shorted means a wire of 0 ohms or negligible resistance is taken and the two ends are shorted. So this is nothing but the load. Here the load resistance value is RL is equal to 0 ohms. So he is measuring the short circuit current and it is coming as around 1 ampere. So he is telling that for this two port network, in port 1 a 5 volt voltage source is connected and at port 2 short circuit current is measured and it is nothing but 1 ampere. Now he is asking, say if the same 5 volt voltage source instead of connecting at port 1, if it is connected at port 2, then what is the short circuit current at port 1? The concept student is expected to know is reciprocity theorem. In this question, reciprocity theorem application is being tested. The shortcut to solve this type of question is direct application of reciprocity theorem. The type of question is very straightforward. The approach students should follow to solve this question is just simply apply reciprocity theorem, which states that according to reciprocity theorem, response by excitation is equal to constant. So if you see here, in any general two-port network, response is nothing but the output. So here the output is nothing but the short circuited load current or the short circuit current at port 2. Excitation or input is nothing but 5 volt voltage source applied at port 1 in this problem. So excitation and input are both same. Likewise, response and output both are same. So in figure A, excitation is given at port 1 and the response also given at port 2 as 1 ampere. In figure B, he is stating that the excitation is now shifted to port 2, that is interchanged. Earlier, excitation is given at port 1, response is measured at port 2, but now excitation is given at port 2 and response is measured at port 1. He is asking what is the value of that response or short circuit current at port 1 in figure B. The concept the student should know in order to solve this problem is reciprocity theorem. Reciprocity theorem states that in any given linear bilateral passive network excited by a single source, the ratio of response to excitation remains constant even when the position of source and load are interchanged. So now we will see term by term. The given two-port network is nothing but a purely passive network containing only resistors. So it is a passive network. It is a bilateral because there is no diode or BJT or FET or transistor present in this two-port network. So it is bilateral. So as there are only resistive elements are present, in this is a resistive T network in which only resistances are present which do not have any initial conditions like inductor or capacitor, hence it is a linear network. It is excited by a single source. So this two-port network is excited by a single source at port 1. So now the if part of the theorem is completed. Generally, any theorem contains two parts, if statement and the then statement. So whatever the statement is underlined using yellow color, that is the if part. If part is separated from the then part by a comma. After comma, whatever is underlined by a blue color line, that is then part. So the theorem always, any theorem goes like this. If all the conditions in the if statement are satisfied, then we can apply whatever is stated in the then statement. So in this theorem, reciprocity theorem, it is given that any given linear bilateral passive network, yes, the network, the two-port network given in the question is definitely a linear bilateral passive network excited by a single source. Yes, only one source is present. So entire if statement is true. So now we can apply the then statement. The then statement states that the ratio of response to excitation remains constant even when the position of source and load are interchanged. So this is nothing but the source and this is nothing but the load, that is short circuited load. So now response by excitation is equal to constant. So in figure A, response is nothing but 1 ampere as given in the question, and the source is nothing but 5 volt voltage source. So in figure A, response is nothing but I, short circuit current, and excitation or input is nothing but V, 5 volt voltage source. So coming to figure B, he is stating that now in the figure B at port 2, 5 volt voltage source is applied. That is, excitation is now given at port 2 and he is asking what is the response in port 1. So this is the figure 1 in which 5 volt voltage source is applied at port 1 and 1 ampere is the short circuit current at port 2. So for this figure A, the ratio of response to excitation is 1 by 5 because the response is nothing but short circuited load current which is 1 ampere and the source is 5 volt voltage source 1 by 5. Now according to reciprocity theorem statement, the ratio of response to source is constant even when the position of source and load are interchanged. If you observe figure A and figure B, here the basic two-port resistive network is same. The only difference is in figure A, source is connected at port 1, short circuited current is measured at port 2. Whereas in figure B, the same 5 volt voltage source is connected at port 2 and the short circuit current is measured at port 1. So now he is asking what is the value of short circuit current at port 1 in figure B. So here clearly we can apply reciprocity theorem. So when reciprocity theorem is applied for figure 1, we are going to get the ratio of response by excitation as 1. This is response and this is source. That is, we are going to get 1 by 5 because the response is 1 ampere and source voltage is 5 volts in figure A. Now applying reciprocity theorem to figure B. In figure B, response is nothing but short circuit current in port 1 which is nothing but I by, we have to find the I value. Excitation is 5 volts voltage source at port 2 by 5. So we get I is equal to 1 ampere. So just by applying reciprocity theorem, we can solve such type of problem without actually applying nodal analysis or mesh analysis. This problem can also be solved by using nodal analysis or mesh analysis technique, but it takes 5 minutes. This is the shortcut. Now consider another question wherein in port 2, instead of applying 5 volts, only 2.5 volts is applied. So what is the value of short circuit current at port 1? So clearly reciprocity theorem is applicable only for linear bilateral passive networks. So clearly if we see the word linear, means here the excitation is divided by 2 and hence the new excitation value is 2.5 volts and hence the response will also be divided by 2, that is 1 divided by 2 which is nothing but 0.5 ampere. As the excitation is halved, the response is also halved because it is a linear network. Thank you.